Okay, so last week you started the unit on climate change, and some of the stuff on climate change is quite familiar. Like, you will have heard stuff before when we did stuff in year 9 about sustainability. Some of this we talked about, so it should, some of it, be fairly kind of familiar to you. However, the first few lessons, there's quite a lot of new vocabulary, and some of you might have struggled with the tasks last week. So this video is just going to go through some of the key learning points and then introduce the idea of, is climate change a natural process? So first of all, I'm going to do a bit of a recap of what you've already learnt about, and then we will look at this as a learning objective, so looking at the evidence for climate change being natural. Okay, so the first thing that you need to do is familiarise yourself with the pack that I sent home for all of you. So in your pack, you'll notice that there's a photocopy of the textbook, and you need to really look and read and make notes, if you haven't done so already, on page 48 and 49 of the textbook, and I've given you a photocopy of that. So yours is in black and white, but you should be able to look at this page. And there's some key points on here about the Quaternary period, which is the period that you need to understand. So long-term climate change has happened over the last 2.6 million years. And the graph, figure D, up in the top right-hand corner of that page, shows how the temperature of Earth has fluctuated in the last 450,000 years. At this, it shows that over the last 450,000 years, there's been 5 interglacial periods. So they're the periods of time where the Earth was actually warmer than it is today, okay? So warmer than the average temperature. However, you'll see in the last 450,000 years, there's been way more glacial periods. So the Earth has been covered in ice far more than it has been in the state it's in today. So we would expect over the next kind of couple of decades that we would start going back into an ice age, into a glacial period where it's cooler, but that isn't happening, as we'll find out in another lesson. So this is a really common graph in an exam, and if you had to describe what this is showing, it's showing that over the last 450,000 years, the temperature of the Earth has fluctuated, and there's only been 5 peaks where the Earth's temperature has been above today's current average, whereas the vast majority of the time we've been in glacial periods where it's actually cooler than it is today. So a couple of things to remember based on what you've learnt so far. The Quaternary is the last 2.6 million years of Earth's history. During the Quaternary, the temperature of the Earth has fluctuated, and there have been 5 interglacial periods in the last 450,000 years. And there's been far more periods that are colder. So glacial periods have been more prominent over the last 450,000 years of Earth's history. One period of time that was a glacial period was between 1300 and 1880. So back in sort of medieval times up to Victorian times. There's lots of evidence of the River Thames in London being frozen solid, and there's been 23 times during those centuries that people could play sport, hold markets on it, which is really unheard of. You know, the River Thames does not freeze anymore. It hasn't frozen since 1880, and this time is referred to as the mini ice age, when Britain was much colder than it is today. So there's lots of evidence of past climate change. There's ice cores, which we talked about in the Google Meet, and it talks a little bit about ice cores in one of the documents in your pack, diary entries, temperature records, fossils, and so on. There's more evidence that's more reliable that climate change more recently has taken place. So that's things like melting ice caps that we can actually see with our own eyes, and rising sea levels in various parts of the world. So our temperature records are more reliable because scientists are more advanced. We can see the weather events. We can actually see the sea level rising and the ice caps melting. And the key thing is that our climate has always changed. And so a lot of people argue that that is an argument for why climate change that we know it as today is not actually happening, that it's just fake news, in Donald Trump's words, and that actually it's all just a natural phenomenon. It is true that our climate's always changed, and there are some natural reasons why that climate and temperature has fluctuated, and that's what today's lesson's all about. So you need to make sure you understand the last few lessons, and that's the few pages in the textbook pack that I sent to you. But then today's learning objective is to understand the natural reasons for the Earth's changing climate. So why has the climate changed naturally over time? And there are three main ways that we can explain this change. The first one is the sunspot theory. The second one is the eruption theory. The third one is the orbital theory, or the Milankovitch cycles. Okay, so what I'm going to do now is talk you through those three different theories, because you need to understand what they all mean. Firstly, sunspots are dark spots on the surface of the sun. So in this image, you can see that there's much darker spots. Now, if you were actually going to look at the sun, which you're not able to do because it can damage your eyesight, but if you were going to look at the sun, you would see that the sun's surface is covered in spots. Sometimes the sun's surface is covered in more spots than others, and these spots are thought to be magnetic storms on the surface of the sun. So they're magnetic storms, and they cause an increase in the amount of energy that the sun emits to Earth. So the more sunspots there are, the more energy that Earth receives. They believe that there's an 11-year cycle. Okay, so every 11 years you'll get more sunspots, and that this will link to Earth's temperatures. And so the Little Ice Age that we talked about in the previous slide, between 1300 and 1870, is linked to a time where there were far fewer sunspots. And then other periods of time have been linked to periods where there's lots of sunspots. So at the moment there's quite a few sunspots. However, as we'll see in a future lesson, that's not the only reason our temperature's changing. So basically, these sunspots produce more energy, and therefore the more sunspots on the surface of the sun, the more energy that is received by Earth, and therefore the temperature of Earth will be higher. Okay. So volcanic activity has the opposite effect of sunspots. So obviously our Earth is covered in volcanoes. You know that from the last topic. So various parts of the world have more volcanoes because they're on plate boundaries and so on. When a volcano erupts, it emits lots of ash and particles, sulfur dioxide, carbon dioxide, water vapour into the atmosphere. And what happens is that dust travels around the Earth and it blocks sunlight from getting to the Earth's surface. So it reduces the temperature on Earth. In 1991, there was an eruption of Mount Pinatubo, which is in the Philippines, and it was a massive eruption. It put 20 million tonnes of sulfur dioxide into the atmosphere. And the Earth's average temperature over the 2 years, 1991 and 1992, was 1 degree on average cooler than it was the previous years. So volcanic activity can have a really significant impact on the Earth's climate and can cause fluctuations. So years when there's lots of volcanic activity, the Earth's climate will be cooler, and years where there's less volcanic activity, the Earth's climate will be much warmer. Okay, so during the medieval warm period, so in the years 950 to 1250, there was way less volcanic activity, whereas in the Little Ice Age, the mini Ice Age, there was way more. So it can also be used to link to the reasons why the Earth's climate has changed over that long period of time. Last reason is to do with space and the orbital theory, or Milankovitch cycles, and it's sometimes called Milankovitch cycles because there was a Serbian scientist called Milankovitch, and he was the one that kind of came up with this theory in the 1930s. So as we know, the Earth moves around the sun, okay? So we orbit the sun, and we also spin on our own axes. So we orbit the sun every year. Takes a year to completely orbit the sun, but we also every single day spin on our own axes. So that's just a little bit of science that you're obviously already aware of. The other thing is we are tilted. So we do not just spin upright, we spin on a tilt, and that tilt varies between 21.5 degrees to 24.5 degrees. The bigger the tilt, the bigger the difference between summer and winter temperatures. Okay, so there's three things going on. Eccentricity is just the change in the way that we orbit the sun. So some years we orbit the sun in a kind of circular motion, and gradually that circular orbit will change to an elliptical orbit, and it takes about 100,000 years for it to change from a circle to an oval and then back again. So when we're an oval orbit, it means that we're much closer to the sun during our summer, but we're further away at other times of the year. So it causes much more extreme temperature changes during the year. Whereas when our orbit around the sun is more circular, we have a much more even distribution of temperature throughout the year. So eccentricity is how we orbit the sun, whether we orbit it circular or elliptical, and it happens on a cycle about every 100,000 years. It changes from elliptical to circular. So that explains some of the patterns that we've seen in history. Okay, it explains some of those fluctuations in warm and cool temperatures. The other factor is the obliquity. And obliquity is, in other words, the tilt of the Earth. So the tilt of the Earth is what gives us our seasons. So at the moment, the northern hemisphere is tilting away from the sun, which is why we're in our winter, whereas the southern hemisphere is tilting towards the sun, which is why places like South Africa and Australia are in their summer and in their warmer months. Over time, that tilt will change until the northern hemisphere is tilting towards the sun when we have our summer, and the opposite in the southern hemisphere. So obviously that tilt has a big impact on the Earth's climate, but the tilt, like I've already said, isn't the same, and it changes over a 40,000 year period. So over 40,000 years, the tilt will change from 21.5 degrees to 24.5 degrees. And with less tilt, summers are cooler and winters are milder. And with a greater tilt, summers are much warmer and winters much colder. So with a bigger tilt, we have much more extreme summers and winters. And at the moment, the Earth's tilt is just over 23.5 degrees. So it's at the higher end of that tilt, and that might help explain why we're getting hotter summers and colder winters over the last sort of 10-15 years. The last thing is the precision. So basically, not only does the Earth spin and it tilts, but it also wobbles. So precision can also be called wobble. And the wobble is caused by the force of gravity. So it makes the axes trace a circular shape, and it basically wobbles. And one other factor that causes the Earth to wobble on its axes are extreme tectonic events like big earthquakes. So for example, the Japanese earthquake that we studied caused the Earth to wobble on its axes, and this happens over a period of 23,000 years, and it again links to some changes in our climate. So this is the page in the textbook that explains all of this, and it should be in your pack, but I have obviously put photographs of this on Show My Homework as well. And you really need to read this and understand the three different factors that cause natural climate change. Okay. So what have I learned? So just a way of remembering it: sunspots, wobble, orbit, tilt, volcanic eruption. And you might want to write that in your books. Apologies for that little break. Tasks today: read through the pages from the textbook that I sent to you, titled, and I've put the titles of the pages that you need to use, and then complete the relevant sheet about natural climate change using the information explained on this video. Some of you might not need to do task 1 in much detail because you've already written notes from previous lessons. Task 1 is a bit of interleaving, a bit of revision from the previous lessons.